I'm Patrick Bailey with IQlist.com. Today is April 30th, 2022, and in this video, I'm going to talk through some ideas and test on making a better 3D printed classroom calipers. Okay, I've already done a video on the good enough calipers where I went and fixed it because I think this overall is a genius design because I would like to see something simple like this. Well, I mean, I like this for the classroom. You know, you could print a bunch out for the classroom, hand them out. I already went over that. It's a really great idea. However, it's got two problems. You know, after I fixed it, it has two remaining problems. One is if you print it out side by side and you want to change the color, and the color you want to highlight here is this arrow and these numbers, they're at different heights. So that's one problem, and that could be relatively fixed. That's why I want to redesign this from scratch. But another problem is this guy. We did fix this gear to work, but the problem with this gear, well, an improvement that could be made is it would be nice if I could print this all in two pieces so that the gear was enclosed. And there's a lot of designs out there where you see that things are enclosed in things within printers when you 3D print something out, and I think that can be done with the gear. And that being the case, you could print these both out, change the color at the same layer height, and then just slot it in and you're good to go. Now also, as I do this, I'm going step by step, I do want to follow the principles that this, on purpose or accidentally did, is it's more like, you know, I want to use the example of like a Kalashnikov rifle, where things are loosey-goosey, but they work, and they always work. If we made it too tight, people might have problems 3D printing it, it might not work right. We want this to work really well in all conditions and be very simple to print out and have very high success rates. So I think I want to keep with that. So with that, I haven't really printed enclosed anything, so I tried a couple of things, and we'll show this in OpenSCAD here in a minute. So first thing I did is I took this and I turned it in OpenSCAD and then gave it some space. But I just did it right to the top. You can see it's kind of a cone shape with a disc on top. And I gave it, there's actually a lot of wiggle in there, but if I'm trying to, and arguably I can spin it by hand, and this idea might work out adjusted, but then I thought, you know, let me go a little bit better and see if I can get it where it would spin really well like a wheel. As it is, it's too loose. If I try to spin it like a wheel, the larger part here is hitting, and that's just too much friction. So I thought, okay, I'll take this and extend the small piece and make an axle. So I did that with this guy, and when I did it, I made the spacing too tight, and so it was kind of stuck. In fact, you can see here I got a little frustrated and took a screwdriver to it to try to break it free. I eventually broke it free. And then I got it, it took a long time to work it, and I got it working, and then I actually had to put in some grease lightning in here, and then now you can probably, hopefully, see, it spins. Well, I can show it, like, let me show there so you can see it. It goes really well. And this might also be some interesting ideas for future ideas. But then I thought, okay, for next test, let me not be so loosey-goosey. Well, let me not be so tight. So this one, I got a little more wiggle room in there. So as I pulled it off the print, I did not have to break it loose, but I did have to work it a little bit to get it moving. But then once I got it moving, and although this doesn't really apply to what I'm doing here, it's still, even though it was on that, if I tried to do this, it wasn't working very well. So once I put some grease lightning in there, and it worked just fine. Now for the purpose of this, I don't think I'm going to have a problem because I'm not going to be using it like a wheel. Now when I took it off the print and I did this, it worked just fine. So I think that's going to be fine for the gear. But for those who might take an idea like this and want to turn it into a wheel on a car or something, you're probably going to have to use some grease. But I don't want to use grease with this. Whatever I come up with, if I have to make it even looser, but it still works, that's fine. I don't want to get it too tight. I want to get it a nice happy medium where it's going to print really well. But anyway, so there's still a lot more to go, a lot more tests to go before I can start redesigning all this, but this is the main key, getting this figured out, and the rest should follow, because now I got to turn this into a gear, figure out the linear teeth. But with that, let's go over some more of the details and show the OpenSCAD I did to get this going. Okay, a couple of URLs, and then we'll just chat a little bit. So first of all, I've already done a video on this, but here is a link to the Thingiverse original one, which I think is a great design, but it needed a couple of fixes. So I actually fixed it and I put it out here on Printables as a good enough calipers fix. You can go find that and download it. Definitely a worthwhile print. It's interesting, and I think it could have a lot of use in the classroom, homeschoolers, just to teach them how to use veneer calipers, and also, just for some, I wouldn't say accurate, but, some rough estimates when you want to go measure some stuff and do some scientific stuff. It's a good tool, I think. And if you go look around, there are actually, I've never printed them, but there are some very fancy calipers out there that you can 3D print that are much more accurate, supposedly, but I've never printed one out. For getting that level of detail, I'd rather go buy one, a metal one. I prefer that. But it is nice to know, assuming they work just fine on those detailed ones, it's nice to know that those are available to you in a pinch, that you could print something out. Heck, a lot of us were kind of locked in our house for a couple of years and couldn't get things. But the goal with this one is simple, classroom, cheap. That a classroom could print 30, 40 of them for the classroom and afford to have them walk away or get broken and not worry about it too much. And as is, the good enough calipers fix I think works pretty well, but I want to do some improvements. And I did a video on that. Video's out there. And also, I'll show you right now this enclosed wheel test. So I did put the OpenSCAD code out there, so you can go download it. It's out there, and there's a link in the show notes. But we'll just show it here real quick. Okay, I also have a split view here. You can set to true or false. So I set it to, let me set it to false real quickly. Because here it is, it's just all enclosed in OpenSCAD, so you can render it and just print it for yourself. Or you can set it to true real quickly just so you can see the cutout. So you can see the cutout here. We come down here and we have a little bit of a gap. And a little bit of a bigger one here as that goes up. And we have the same gap up here. There you go. In fact, I may need to fix that. There's a problem right there. That gap probably needs to be a little better. Well, no, I kind of like, debate. But this is just a start, just a test. But you can see something like this, although you could do this in Fusion 360 just fine, and there are some parameters you can adjust in Fusion 360, but if you want to do a bunch of tests like this to kind of nail down what the best distance is, it's a little bit easier to do it in OpenSCAD with variables. You can quickly change it, and yeah, you can do it in Fusion 360, but I find OpenSCAD a little quicker for this, and you can tweak it and adjust it and re-render it, and then go from there and do these tests. So the code's out there if anyone wants to fiddle with it. You could probably, I was looking around and thinking what else you could do with it aside from you could, somehow do wheels. But there is also the idea, because it rolls pretty good. If you change the wheel to something a little more bumpy and bigger, of course, you could probably do a print in place, one of those little back rollers. I thought about that. You could probably make a little back roller to massage yourself or massage someone else, like that camera crew I have. I should probably make one. Camera crew's my wife, if that joke didn't come across too well. But anyway, there it is. It's out on OpenSCAD. It's out on GitHub, so you can go download it, check it out. But there's more to come. I really want to get this classroom calipers done at some point. It might take weeks, it might take months, but I want to get the simple design down so it'll be really useful in the classroom. And, for homeschooling, we're homeschoolers, and it's kind of nice to have tools like that available to you, which is another reason I try to encourage all the homeschoolers to get 3D printers, because there's all kinds of cool designs you can print out that are useful in your classroom, and every day we're getting more and more and better. And at some point, I think every homeschool needs a 3D printer. There's too much good stuff out there right now, and at some point you're not going to have an excuse. You're just going to have one. So with that, let's wrap it up with this reminder that 3D printing is an adventure that you're on. You can develop your skills and knowledge and take this in so many ways. You can make a business out of this. You can teach others. And you can make some amazing designs. And I hope to make an amazing design with this classroom calipers I'm working on. So design it, engineer it. I have a new Bondtech extruder for my Prusa Mini. I got frustrated with some extrusion issues, which I fixed. But in my frustration, I purchased this, which I'm kind of happy about. We'll see. I have not yet installed it, but I think it will. Once I get it installed, I think it will make some improvement, but probably just a subtle one. I'm certain it would not fix the issue I did have, which was just a nasty clog in my extruder, which I had to pull out, and it was not fun, but I got it fixed. Even had to go burn it out, but I got it fixed. And I think this will be an interesting install, and I'll video it when I do it. But subtle, better. But overall, I'm pretty happy with my Prusa Mini. I've had a few issues here and there over the years, and I abuse it a lot. But we'll see. We'll get this on, and we'll see if I notice any improvements, or if it just, I've been using it for a while. Maybe it's just time for some maintenance, and this might be a little bit of an overhaul.